Welcome to today's SilverlightShow webinar. My name is Svetla, and I'm pleased to introduce you to today's webinar presenter. This is Peter Kuhn, and he will speak today on raw camera access on Windows Phone 7. Perhaps you already know Peter. He has delivered several webinars on Windows Phone already, and he has also authored a number of SilverlightShow articles, as well as some SilverlightShow ebooks. And in today's post-webinar survey, we'll also be giving as an award for substantial for good webinar feedback, one of his ebooks. This is the Windows Phone 7 preparation, exam preparation ebook. So this webinar session will continue for about 60 minutes, as usual. And we'll have a short Q&A session at the end. So if you have any questions during the webinar session, just feel free to type them in the questions panel in your webinar panel. This should appear on your right. And Peter will reply to all questions at the end of the webinar. All right, so Peter, you can now go on.
Okay. Thank you for this very nice introduction, and welcome everybody to this webinar on raw camera access on Windows Phone 7. First of all, let me introduce myself quickly to you. I'm Peter Kuhn. I'm 34 years old and known as Mr. Good Cat in the community. And I'm working as a senior consultant and architect for .NET, Silverlight, and also Windows Phone 7 for applied information technologies. And I'm also working as an author for technical articles, for example, on SilverlightShow. I'm an MCPD for Windows Phone 7, Silverlight, Web Enterprise Applications, and I've won the Microsoft Community Contributor Award in 2011. I hope most of you already know my free Windows Phone 7 trainings, which are available on goodkattrainings.net and also my blog on ptalk.de. You can also find me on Twitter and follow me and ask questions and contact me on Twitter. Like I said, today we will talk about camera access on Windows Phone 7, and first we will take a look at what the state was with Windows Phone 7 in the RTM release, and then we will take a look at the changes that were introduced with Windows Phone 7.1, also known as Mango, and also some of the upcoming changes that are part of the version 7.1.1, which is currently available as technical preview. We will see that we have two programming models to access the camera on the phone, and we will have, of course, one of the live coding sessions. I know you people all like those live coding sessions most, so I will keep the time on the slides short. And then in the end we will quickly sum up what we have seen today and also take a look at additional resources you can take a look at. So let's start with a look back at Windows Phone 7 RTM, which was based completely on tasks, in particular the camera capture task that hands off the handling of obtaining an image to the operating system on the phone. And when the user is finished taking the photo, the image is returned to your application. This means that this process is highly dependent on the user, and you have little options, actually you have no options for this particular task to set and to influence how the picture is taken, and even whether the user decides to take the picture at all. They might return to your application without having taken a picture or navigate away from your application completely without ever returning. Still, even with the new camera access options for the 7.1 release, this is the recommended way for certain situations where you simply want to get a single image or want to have the option that the user takes a single photo. Microsoft still recommends using the task, because it's simpler to use than embedding direct camera access, and it's also a benefit in low memory situations, which we will take a look at later, because the memory consumed by this capture task is not added to the memory consumption of your application, so this performs better in these situations. Windows Phone RTM had no direct or live access to the camera. And that, of course, is what has changed in Windows Phone 7.1, where this live access had been added, and this gives you full control of a great variety of options like the resolution, the flash settings, focusing the camera, focusing on particular points the camera is looking at, and taking photos and thumbnail pictures of what is seen through the camera. Mango also has added support for new hardware features, like in particular for the front-facing cameras, where you can that you can use for applications like video chats, for example. Of course, there are not a lot of devices available yet that have these additional hardware features, but they will come out in the near future, and there are ways to easily test for these. We will see that in a moment. The upcoming update to Windows Phone 7.1.1 brings support for 256 megabyte devices, and this will also have a new memory cap per application that is pretty low, and this can be critical if you decide to embed live access to the camera into your application, because this naturally consumes a lot of memory, like obtaining the images, everything that has to do with media always is memory intensive, or more memory intensive than other simple applications. We have two programming models on the phone to access the camera in Windows Phone Mango, one of which is newly introduced to the Windows Phone platform with this system update, and this is mostly meant to access the camera for still or photo applications. You can get periodic updates and also a live view, a live video view using these APIs, but the intention is to use these APIs for still image applications. And then we have a second set of APIs that is compatible with the APIs available on the desktop on Silverlight 4, and these are the webcam APIs that are meant to be used for video applications. In this webinar, and in particular in the live coding session, I will focus on the new Windows Phone APIs, because the Silverlight APIs really are compatible with what we already have on the desktop. So there are plenty of tutorials out there, videos and other resources. I will link to some of these at the end of the webinar. So I will focus on those parts of the API that are newly introduced with the recent updates. Let's take a closer look at the new Windows Phone APIs. This gives you access to a so-called live viewfinder, which is a live video stream you can access and embed in your application. And you can use this API then to capture images and also thumbnails directly to files or to streams in JPEG format. And like I said in the beginning, you have full control over all sorts of details regarding the camera settings. And for more advanced scenarios, you can also access the raw viewfinder images that are delivered through this viewfinder, through this photo camera object. And this is a very interesting option, for example, to do some live processing of images, to add effects to the images, to build applications that may even add some sort of augmented reality features. And we will also take a look at how to get and how to work with these raw images in the second part of the live coding. And one last very interesting option that has been added to the APIs is that you now can configure the hardware camera buttons. The single button, it's only one button. But the button has multiple states. Usually you can push these buttons halfway down to trigger a focus of the camera, and then a full push of the button takes an image, and you are free to configure the functions of this hardware button in your application as you like. The second API, like I said, is the one we already know from desktop Silverlight. It works with source and sync, with the source and sync concept of Silverlight, where you define video capture devices and audio capture devices and can wire these up to syncs that consume the video and audio that is delivered from the hardware. And the only thing that's really different from the desktop API is that we have a new sync type on the phone, which is named file sync, and that lets you store a MP4 video directly into isolated storage. Like I said, this API is not part of this webinar, but if you're interested in it, take a look at the resources in the end, or feel free to ask questions in the Q&A or offline later. So there we go. We are already at the point where I switch to the live coding session, and we will build a quick application from scratch that embeds the photo camera, the new photo camera class. Shows you some of the options, how you can configure this class and how you can use the class to show a live video preview of the camera stream in your application, how you can take images, and how you can access the raw data that is coming from the camera to add some effects to the images. Okay. So I will literally start with File New Project here, and let's place that in a webinar folder and name that photo camera sample. You may have seen some of these tutorials that already explain the photo camera class, but I hope that on the way, as I explain some of the details, you will still learn new things and see details that are not explained in those other tutorials. Okay, so the application I'm going to build will split the main page into a left and right half, where you can see the live image on the left side, and the right side will be reserved for example, the images we will take from the photo camera, the stills we will take, and we will have some buttons that allow us to manipulate some of the settings for the camera. So the first thing I do is I will go and throw away all the default content here and replace that with a stack panel. And within that stack panel I will place two other stack panels, but this time with an orientation of horizontal. And the second one will be where we will place our buttons, something like that. We will add more buttons later, but just so you get an idea what this application will look like, I will add one as a sample. And the way this live viewfinder works is that you can use this as a source. You can use the camera class, the camera object you obtain, as a source for a video brush. So what you can do is you can set this video brush as a background brush for any suitable element in the visual tree here in XAML. And usually what you would do is you would use an element type like canvas, for example. So let's make sure that half of the screen is covered by this live view background, and this is where we will later set the video brush. Well, let's leave that out for a moment, and the other half of the screen will be reserved for an image control that will show the captured and images that we have applied effects to, and we will set the source of that image later when we have the appropriate code for this. For simplicity, I will set the supported orientations to landscape and the current orientation to landscape right. That is the way the user would usually hold the phone to take a photo. The photo object itself has a property that allows you to obtain information about how far the camera is rotated compared to the upright position of the phone. So usually what you would do is on the orientation changed event of your page, you would adjust the live view you have in your application so the user sees the same, sees what the camera delivers in the correct way. Let's also hide the system tray here. Okay, so this is the basic layout of the application. Let's see if we have a preview here. So this is what it looks like. The buttons are at the bottom and our live view and image control at the top. So what I will do before I start coding is I will add some helper classes that I'm using in almost all of my projects in some way. These are not related to the camera topic at all. They are simply there to make it easier to work in an NVVM-like manner. I don't like putting all the code in the code behind file of the main page. So even for simple samples, I'm trying to go with the NVVM pattern, so I have a clear separation of code and view. And to help that with, for our quick sample here, I have simply added two helper classes that allow me to easily implement iNotify property changed supporting properties and to expose commands that my view can bind to. If you don't understand NVVM in more detail, then you can join my next webinar, by the way, which will be about NVVM on the phone. But it's not relevant to understand the code that is involved for setting up and using the photo camera object. So if you are not familiar with NVVM, this will not be a problem here. Okay. So let's go ahead and create a view model for the main page, which is the class that holds all the code that will drive the logic behind that page. View model base. That is the base class that is defined in one of these helper classes. And setting up the camera now here in the code is really easy to do. Most of the features that you will want to use in your application are located in the photo camera class, which is part of the Microsoft.devices namespace. So let's add a field for this to our class, and now we need to initialize. We need to create and initialize this photo camera object, and there's a certain pattern to follow in all Windows Phone applications, because all the applications are page-based and have this navigation concept of transitioning between different pages. The pattern is to set up and to initialize all the resources that are precious and take up memory and potentially occupy hardware of the device in the onNavigated_to event of a page, and at the opposite time, when the user navigates away from the page, you want to clean up and free those resources you have occupied before. So what I'm going to do is I will add a onNavigated_to method to my view model, and I will call an initialize camera method from here. And at the time the user navigates away, which is when the onNavigated_from method is called, I will clean up the camera again. To initialize the camera, all we have to do is create a new object of type photo camera, and again, to make this a bit more separated, I will move that to a separate method. So, and here is the first thing, the first new features you can make use of, because there are some static methods available on the base class of this photo camera type, which is named camera. In particular, this isCameraType supported method that you can pass in a camera type. We have two camera types at the moment, front-facing and primary, and that is the way you can determine whether the current device your application is running on supports a front-facing camera or only has the primary camera, which is available on all devices. So if you are interested in a front-facing camera, you can check this and, for example, return a new photo camera object and have it use the camera type front-facing. Okay, and if we don't have a front-facing camera, I will check for the camera type primary and return a new primary camera. Okay, and in case we don't have a camera, which is not the case on any devices on the market right now, but just to be nice, we return null here. Okay, so let's say your application is interested in the front-facing camera because it really only makes sense to use the application when there is a front-facing camera. Then there is a way to signal to the marketplace, actually, that your application absolutely requires such a front-facing camera, and that is done in the WM app manifest XML file, which defines the hardware capabilities your application requires. And you can see that we already have one related to the camera here, and this one that you can see here only says that a camera is, the primary camera is required, and you can add a second one here, capability, and it's named a bit different. It's named ID HV front camera. Front camera. And the important thing to know is that you absolutely should only add this capability here if you require a front camera. If your application can use both cameras, then don't add this capability here, because this will force, this will signal to users that your application absolutely requires this camera, and users will not be able to use or won't download your application if this capability is set and they don't have a front camera on their device. So if your application can work with both, don't use that. But that's a way to force this, so you can make sure that your application only runs on those devices that support it. Okay, in the onNavigated_from event, like I said, I check if we have a camera, and if we have one, I call the dispose method on it to clean up the resources. Once created, you can continue in this initialize method here. Make sure we have one. You can continue to for example, hook up events. This photo camera type works a lot with events. For example, every action that you trigger to get images, to focus the camera and things like that are kicked off and are running in the background, and when they have finished, you are notified about this by events that are raised on this object. So one of the events that you want to hook almost all the time is the initialized event, because you can only work with most of the features on the camera and the settings on the camera once the camera has been initialized. It's not a valid thing to access, for example, settings of the camera object just after you've created it. You need to first wait until the camera object is initialized. So in this event handler here, it's safe to, for example, manipulate the camera. But one important thing to know is that these event handlers all return on a background thread, on a thread from the thread pool, which means whenever you want to, for example, access directly or indirectly elements of the UI, update the UI with, for example, images you have taken, you need to marshal this call back to the UI thread. So you would need to do something like deployment, current, dispatcher, begin invoke, and write your actions here. Okay? So I'll leave that in. We need that in a moment. And once created, there's a second step we want to do. We want to get the live view of this camera object and show it in the main page, in this canvas element that we created. And the way to do that is to, like I said before, to create a video brush. So let's go ahead and add a video brush property to our view model here. And to do that, I will use this support for property changed events that my base class provides. This will be a video brush. Oops, that is not what I wanted. Let's try it again. Video brush. I name that camera brush and introduce a field for it. So that's the property for now. Let's wrap that in a properties region so that we can hide it, because we will add some more properties later. And when the camera is created, I will also create my video brush. And the nice thing that we can do is we can set the source of this brush directly to the camera object. As you can see by this tooltip here, I hope you can see that. This is an extension method. So someone created a method that takes this camera object, or can take this camera object and use it as a source for a video brush. And once this step has been performed, the initialize event will be raised on the camera. So this is what actually triggers initialization of the camera object. Okay. So now we have exposed a camera brush, and we can use that in our view in the canvas element here to set the background. Okay. At the moment this doesn't work yet because we still need to wire up the main page to a main page view model. So instead of using any framework or helper classes for that, I will simply do that manually here. So I will create a new view model and set the data context to that view model. So at this point we have all the properties that the view model exposes available for data binding in our example. And what I will also do is, of course, I will override the onNavigated to method and call viewModel.onNavigated_to, and I will do the same for the onNavigated from viewModel onNavigated from. So that's all we need to do to wire up the viewModel and the view. And from now on we can simply bind all the properties of the viewModel to our elements here. And I hope if I run this application in the emulator we can already see a live camera view. So let me run the application for a moment. Okay. There you go. This is what the emulator presents when you use the photo camera object, because obviously the emulator has now no camera built in, and it also unfortunately has no feature to, for example, hook up a webcam that is connected to your computer to use this as a camera replacement for the emulator. It simply generates an image, a moving image like that, so you can see that it's actually working there. So this is what is supposed to be the live view. And we can also see our button down here. So nice, this already works. Now the first and probably the most interesting part, or the part people are most interested in, is how to make use of this and to capture images. So let's return to the view model and let's take a look at what the camera offers. And you can see that there's, for example, a capture image method. And once again, this works in a kickoff and receive the event, the corresponding event cycle. So we need to hook the capture image available event. This will be raised once the image is available. And we want to kick that off when the user hits the small button that I have added to the view in the XAML in the button area. So what I will do in the view model is I will expose a command for this that can be bound to the button in the view. Again, if you're not familiar with MVVM, this is not relevant for the actual camera code. So capture image command, get a private set, and I will use the constructor of the main page view model to create this command. Capture image command is a new relay command, and I will simply relay that to a capture image method that I will create. Okay, so let's actually add a region for this here. This is initialization. What a difficult word to type. And let's create a second region for the capturing images task. So we have our code separated cleanly. So in this capture image method that is invoked when the user presses the button, I will simply check if we have a camera. Always be nice and check if you have the object that you want to access, and kick off the capture image method. And once the captured image is available, this will automatically raise the event, the capture image available event, and this event handler I have created for this. On our way down here, let's actually go ahead. Oops. Let's actually go ahead and remove these event handlers. Camera on initialized, and also the second one, image available camera. Camera on capture image available. So to clean up the event handlers that we have added above in the onNavigated from also. Okay, so once the capture image capture image available event is raised, you can access the image using the content ready event arcs that are passed into this event handler, and you can see that there's a single property that's interesting for us, and that is a stream. And this stream contains the full resolution image that has been taken from the camera, by the camera, in a JPEG format. So once again, before we can do anything with this, we need to marshal this back to the UI thread, because eventually we want to show this image on the UI in the main page. And before we can do that, we first need to make sure that we are on the correct thread to access this UI element, or to pass on this image to the UI element. What I will do is I will create a new bitmap image for this. And this has a method setSource that takes a stream. How convenient. And I will simply take the image stream that has been returned by the camera. And what I need to do now is I need to expose this bitmap image I have created in some way so the UI can make use of it. So let's create a new property for this. And I will add that to the properties up here. And the usual type that is exposed for as a source for a image control in the UI is image source. And bitmap source, the one we created, implements image source, or derives from image source, so we can safely use the bitmap image as image source for the image control we have in our main page. Image source, image, and done. So let's return to the main page, and we already have this image here, and all we need to do is set up the binding that tells the image control that the source can be found in our view model in the image property. Okay. And the last thing to do is to wire up the button that we have created with this capture image command. And that, of course, also is done using a binding. So once again, the user clicks the button, the capture image command is invoked. This is simply relayed to this capture image method, which kicks off the capture image method on the camera object. And once the image has been captured, we will be in this event handler, marshal back to the UI thread, create a bitmap image from the result that the camera provides, and through this image property of our view model we have created, this image will be exposed and shown in the UI. So let's take a look at the emulator again, which now is in the background. And you can see when I click the button, the image control shows something that is completely different from what we have seen in the live finder, in the live view. This may be a bit confusing at first, but this is actually intended. The image shown here is what is supposed to be seen what is supposed to be returned on the emulator when you use the capture image method of the camera object. So don't be confused. This is exactly what should happen. I will show you a nicer example in just a moment. Okay. So as you can see, the actual code that involves the camera required to obtain an image, to initialize the camera, to show the live view, to get an image back from the camera is really little code. So this part of the API is extremely easy to use. Now, Let's say that you want to adjust some of the settings of the camera. For example, you want to use the focus to focus at a certain point. You want to switch on or off the flash, or you want to select a certain resolution. Then how would you do that? The camera object has a lot of properties and methods you can use. For example, things like using the focus is done by using the corresponding methods like focus, which does a general autofocus operation. Or you can also use focus at point, which is a relative point on the viewfinder, live view. So you can, for example, allow your users to tap directly on the live view at the point the camera should focus at. You simply need to translate the coordinates of the tap point to a relative coordinate that is expected by the focus at point method here. You can also cancel the focus operation. Focusing can take a lot of time, for example, on a bad light, so you can cancel this. And again, when the focus operation is completed, you will be notified about this by using an event. So this is the way to interact with the camera using methods. But we also have the possibility to, or some other settings are set up by using properties. For example, the resolution the image should be taken at. So we have a collection here, an IEnumerable actually, that is contains the available resolutions on the camera, and we can iterate over these to see which ones are available and give our users the choice of which one they want to select. And if we have decided, once we have decided for one resolution, you can simply set that by using the resolution property of the camera object. And from that point on, the camera will return all images that you capture in that resolution. Okay. The same is true for the flash mode. The flash mode also is a property on the camera object, and you can set this to a value of the corresponding flash mode enumeration. For example, you can turn the flash on, off, to auto, or to red eye reduction mode. One thing you should be aware of is that not all cameras support all flash modes. So there's a method to test whether a certain flash mode is supported first. The emulator does not support switching between different flash modes at all. So if you try this on the emulator, you will see that it returns false for all the supported, for all tests of supported flash modes. Oops. Okay. So one thing I want to do is I want to show you how you can access the raw buffer of the live finder, for example, to add effects to your to the images that are returned by the live view. So to do that, I will add another button and another command to this view model here. A relay command named capture preview buffer command. Get capture preview buffer, which I will simply relay to a method. And let's put that down here to the capture region once again. And again, the way to do that is pretty easy. Let's see if we have a camera. And the way to do this is to use one of the get preview buffer methods. These methods are named after the format of the pixel data that is contained in the buffer. where you have different ways and different formats you can retrieve. For example, ARGB format, which is the most common and most simple, the simplest format to work with. And you can also use the luminance data for grayscale images and the luminance and chrominance data to work with colored images. I will talk about this a bit more in just a minute. For now, we will use the ARGB format that is easier to use, and I will explain what this data means and how it works in a moment. The way this method works is that it copies all the data that is currently in the buffer to a byte array, to a integer array that you have defined by yourself. And this integer array is a flat representation of the whole image. It contains all the pixels that are part of the image in one-dimensional flat integer array. So to get the size of this array, you actually have to use the preview resolution of the camera object, and there the width, and multiply that by the height of the preview resolution. So this calculation is the total amount of pixels that one preview image contains, and we create a buffer that is big enough to hold this complete image. And that's basically all to do. And what you can do now is you can iterate over these pixels and do whatever you want to do with them. And once you're done, you can, for example, use this buffer to create a writable bitmap from it and display that writable bitmap in the UI. Now, this is where things become a bit complicated. Let me switch back to PowerPoint for a moment, because I have one slide that explains how this pixel data works. Let me go down here. This is partly taken from the MSDN documentation. So let me explain what this integer array actually says. It's a flat integer array, and every value represents one pixel. An integer value is a 32-bit construct, and of these 32 bits, each component of the pixel, which is a color or the transparency value, has 8 bits of memory to represent the color value. And you can see how this works in this small image here. We have a transparency value, we have a red component, a green component, and a blue component, and combined this forms one integer value. And this also forms one pixel of the image on the screen. So to work with these images, you can extract all these individual color values. The transparency will always be opaque when an image is returned from the camera. You can extract all the color values and manipulate these. For example, you can turn these into gray values. You can invert those to create an inverted image. You can add your filters, your effects to these pixels by extracting these color values, putting them back into this integer array, and then creating a second image from that. The arrangement of the pixels within the array is from left to right and top to bottom, which means in this small example here, we have an original image that is 4 by 3 pixels in size, and the integer array that is returned by the camera will simply lay out these pixels as rows. And to restore the original dimensions of the two-dimensional image, you would use this left to right and top to bottom arrangement. This one is the easy formats to work with when you work with the raw image data. The luminance and chrominance format is much more complicated to work with. It's not rocket science, but you have to go to the MSDN documentation to take a look at that, because it's out of the scope of this webinar. The luminance and chrominance format is much more efficient to work with because it's smaller and it can be faster processed. But for average and for simple applications, you're fine to work with the RGB format too. Okay, so one thing I wanted to do is I wanted to show you as at the end of the webinar, because I knew that we wouldn't be able to finish the sample application. I want to show you a live preview of the final application. This application will be part of the download package that will be available for you after the end of the webinar. And I hope that I will be able to deploy the application to my phone. So this is a bit of a premiere here. Okay, and I have actually hooked up a webcam where you can hopefully see the application as you can download it after the webinar. And you can see that we have the live view here at the left. We have the capture button here down at the bottom left that we have already implemented. And if I click that, let me click that. It used a flash, took a picture. The picture is visible at the right side. And I have added some more features for you to learn about the camera. For example, you can switch between various resolutions here. You can see that on the camera I have 12 available resolutions here. The emulator only offers 2. And the image that you take will be using this resolution that you set. You can trigger a focus operation here, and I've also added one of the possible filters that just crashed Visual Studio, sorry, to invert the image that is taken. Okay, now it has completely crashed, sorry for that. I will make sure that the code that you get is running well. Let's take one last attempt to do that without the debugger. Okay, so as you can see, I have added a simple invert filter that inverts all the colors of the image that is taken from the viewfinder. Okay, so I have fun with this sample application which builds on the one that we have started to create in this webinar. Okay, to sum it up, starting with Mango, we have options for live access. Raw camera access is really easy to do at first, but it can become quite complex if you, for example, want to get into processing the raw images. Phones only have very limited computing power, so don't expect that you can, for example, apply great effects and still maintain a frame rate that is real time. You will see that with advanced effects the frame rate will drop to very low values. So performance optimization always is something you should keep in mind. And that, of course, requires quite some experience and advanced knowledge of algorithms and image processing technology. So what seems easy at first can become quite stressful later when you try to optimize and try to implement effects. And as I said, memory limitations become even more critical once we have low memory devices on the market. I have added some resources for you. You don't need to copy them now. You will be available to download the PowerPoint presentation after the webinar, and you can conveniently use the links to these additional resources from within the presentation. And that brings us to the Q&A session.
Okay, so we have a couple of questions so far, Peter. I'm assigning them to you.
Mm-hmm.
Okay, can you see the first one?
Yeah, here. So, can you add a mask to the live viewfinder? I'm not sure what is meant by mask. You can paint on top of the live viewfinder as you like. For example, if you want to add elements that are shown on top of the live viewfinder image, you can do that. And if you need to do more advanced things like filter parts of the image, then you would have to access the raw buffer and perform this manually by manipulating the buffer data that you retrieve. A second question is there any generic method to capture the grayscale from the image if you don't want to process color? That depends. You can use let me switch to that. You can use the get preview method that only returns the luminance values. So that will actually only return the grayscale data. But you still need to extract that grayscale data from the buffer manually. If you take full resolution images by using the capture method of the camera, then you will have to calculate the grayscale image manually. There are some pretty easy algorithms available for that. You should be able to find those or contact me so I can send you the links for these, how to convert images to grayscale. I think there's even a code sample from Microsoft available that converts the camera image to grayscale. And the third question here is there a way to directly obtain MP4 output to a stream rather than saving it to a file? I'm afraid no. The file sync that is part of the Windows Phone API saves MP4 video directly to a file, but I think the video sync type that is available does not perform this encoding. I can double check on this, maybe I'm wrong, but I'm pretty sure at the moment that there's no way to directly obtain MPEG-4 encoded video.
Alright, so we don't have any more questions coming up. So if anyone has another question, feel free to tweet or email editorial@SilverlightShow, you know, our Twitter account, as well as Peter Kuhn's. So feel free to send any questions you may have after the webinar, and we'll try to respond to them with Peter. Oh, okay, so we have just one final one before we close. It has just come up in just a second. Okay, you should be seeing it already. Do you see the question, Peter?
Oh, yes. Do you expect any problems using the camera with Windows Phone 7.1.1? That's difficult to say for me because I have not played with the technical preview yet, but I know that some of the documents say that due to the limited memory that your application will get, it can become a problem. Imagine that, for example, when you take full resolution images and take them with a really high resolution, the resolutions go up to several megapixels on these devices, then they come in as JPEG encoded images at first, but if you want to do some manipulation on these images, you have to basically unpack them and have them in memory as raw bitmaps, which means they take up really a lot of memory. And I can see how this can become a really critical part of a image processing application, and where 90 megabytes maybe is not enough to handle scenarios where you want to, for example, apply effects to full resolution images.
Okay.
But yeah, okay. Yeah.
That was it? Yeah?
I think so, yes.
Okay, so thanks everyone for joining this webinar. You're welcome to join the next webinar by Peter. It will be in about 1 month, I think. You can follow SilverlightShow website and Twitter account to learn about the next webinars by Peter. So I invite our attendees to complete our webinar survey and send their recommendations and impressions from this webinar, so we can improve the next ones as much as we can. So thanks for your time, Peter, and thank you to our attendees for the time spent with us. So see you on next webinars.
Thanks for having me, and I hope you all enjoyed it. See you next time.
Yeah. Have a good day or evening. Bye.